How's it going, ladies and gentlemen? Mr. Johnny here again, looking at 16.3 and 4 stuff, where we're going to be talking about autoionization of water and the pH scale. So our objectives are to use the KW for autoionization of water to determine the concentration of H plus or OH minus in solution. We want to be able to convert between pH and POH and the H plus or OH minus concentrations. We want to describe ways of measuring pH, and we want to be able to given the concentration or pH, estimate the other thing. So if you're given concentration, estimate the pH. If you're given pH, estimate the concentration. Cool. So let's get started. So autoionization of water. Auto, again, means just by itself, and ionization is to break up into ions. So we have water, and it will ionize on its own to some extent by breaking down into H plus and OH minus ions. So you can see that with what I got shown on the screen right here. So H2O will break down into an H plus ion and an OH minus ion, right? Which is what we got going on here. So now if we talked about the KQ for this equilibrium, we're going to call it something special, W for water, right? KW. So this is an equilibrium reaction. H2O is going to break up into its ions. Its ions are going to combine to give you H2O again. This is what the equilibrium equation is going to look like, right? H2O liquid giving us H plus aqueous and OH minus aqueous. So remember that liquids are going to drop out of our KW expression. So we're left with just concentration of H plus times concentration of OH minus. And at 25 degrees Celsius, this is going to have a value of 1 times 10 to the minus 14. So we get into the pH scale, which is, pH is negative log of H plus, which you've probably seen before. And a pH is considered neutral when the H plus equals the OH minus. So for water at 25 degrees Celsius, we know the KW equals 10 to the minus 14. And if H plus equaled OH minus, let's call those both X, solve for X. X is 1 times 10 to the minus 7. And you plug that into our equation up here to solve for the pH, and that gives you a pH of 7. And that is why 7 is considered neutral on the pH scale. So we know KW is 10 to the minus 14. We know that KW has to equal H plus times OH minus. If H plus goes up, then the OH minus concentration has to go down because KW has to be constant. And vice versa. If we increased OH minus, H plus would have to go down. So for acidic solutions, we have H plus being more than the OH minus, and that'll give us a pH of less than 7. For basic solutions, it's the opposite. We have less H plus than OH minus, so we have a pH of greater than 7. All right, estimating pH. You can estimate the pH by looking at the concentrations of H plus, which will probably be given to you in the problem. So the exponent will tell you where to start since it will be related to the pH. So for example, 10 to the minus 1, if that's your concentration for H plus, pH is 1. 10 to the minus 2 for your molar concentration H plus gives you a pH of 2. 10 to the minus 13 gives you a pH of 13. Okay, so if the number before the scientific notation is greater than 1, and is describing the concentration H plus, the pH will be less than the exponent as the concentration H plus is greater. Let me just show you what I mean by all those words. All right, so they give us a concentration of H plus. They tell me that it's 1 times 10 to the minus 1. So I'm looking at this. That minus 1 is going to tell me that it's going to have a pH of about 1. And because it's exactly 1 right there, I know it has to actually be exactly a pH of 1. So if I had 2.8 times 10 to the minus 2, well, I'm going to look at the exponent first, and the minus 2 is telling me that it's probably around a pH of 2. Right? This 2.8 is telling me that I have a higher concentration of H plus than I would with something that had a pH of 2. So if I had a higher concentration of H plus, that tells me that the pH is going to be somewhere between 1 to 2 because it's more acidic than pH of 2. But it's not acidic enough to give me a pH of 1. So I'll get this one, 8.7 times 10 to the minus 13. I look at this. All right, if this is my H plus concentration, that minus 13 is going to tell me that it's around 13. And this 8.7, since it's a number greater than 1, it's going to tell me that it's going to be more acidic than 13. So the pH I can estimate is going to be between 12 and 13. 4.6 times 10 to the minus 8, same deal. I look, this minus 8 is going to tell me that it's probably around pH 8, and this 4.6 is telling me it's more acidic than that. So I know it's going to be between a pH of 7 to 8. All right, pOH. It's pretty much like the same thing as pH, except with OH minus instead of H plus. All right, so pH plus the pOH is going to equal 14 always, right? So here I have the pH scale, and it also gives you the pOH scale up top. And if you notice, if you add the two together, it's always equal to 14. 7, pOH of 7 gives me a pH of 7 as well. pOH of 6, pH of 8. So you got to know that that relationship exists. It's because of the KW relationship, right? They have to multiply together, give us 10 to the minus 14. It's how it works. All right. So what is the solution, or I'm sorry, what is the pH of a solution that has a pOH of 2.8? So I can do it a number of ways, right? So I'm going to go, hey, I know that 14 has to equal the pH plus the pOH, which is 2.8. So pH is going to have to equal 11.2. Did that in my head. I'm awesome. All right, what is the pOH of a solution that has a pH of 8.5? So again, I'm going to do the same thing. 14 has to equal 8.5 and the pOH. So I'm going to go, all right, well, what is that? It's going to be 5.5, right, is the pOH. So that's how you do those kind of problems. All right, more about pOH. What is the H plus concentration of solution with a pOH of 8.0? All right, so let's do this. There's a couple ways we can do it. All right, well, if I know the pOH is 8.0, I know that the pH is going to have to equal 14 minus 8.0, which is going to give me 6. I also know that the pH is going to have to equal negative log of the concentration of H plus. So now I got to plug and chug some things, right? So I'm going to go, how do I get H plus by itself? Well, I'm going to have to do 10 to the negative pH equals the H plus concentration. So I do that, and I get 1 times 10 to the negative 6. And that would be the scientific notation for my concentration of H plus. Pretty straightforward, that one. And I got to erase all this because it's in my way now. All right, so next question. What is the OH minus concentration of solution that has a pH of 2.0? So I'm going to do the same thing. I know the pOH is going to equal 14 minus the pH, which is 2.0. And that's going to give me 12.0. Now I know the pOH is also equal to the negative log of the OH minus concentration. So now I do the same thing, I rearrange some stuff, and I'm going to get 10 to the negative pOH equals the OH minus concentration, which is going to give 10 to the negative 12 molar. So that's how I do that problem. And that's the section. So hope you found that helpful. Bring some questions to class. I'll see you there. Okay, bye.